All right. I'll tell you something that's been interesting. I've been looking at the channels and stuff since we're going on Rumble, and we've gone on YouTube and all of that, and the the viewing hours since we started this little series has been incredible. I mean, uh,
Yeah.
you go look at it; it just has like this line board just shooting up, and we just put it on Rumble, and I think the last week's episode, would we already have like 15 views? we
Yeah.
don't even we ain't even really got it streaming there yet, so people are already seeing it. So um, we're gonna uh, have that over in Rumble if you want to go over there. That's where I'm gonna be uploading all the new videos um,
How's it?
for the publications and stuff as we do them too. So, but other than that,
Definitely.
now last week we were still doing size and overcurrent devices, and one of the things that we were doing last week was doing the transformers. All right, now we're going to do the exercise problems here, and then after we get through this, then we're going to start on motors. Okay, and I'm going to go through and explain all this, but I just like I've started at the start of every one of these on overcurrent protection devices. I've gave a rule of thumb, and I've said if you take it at 125% or less, go up to the next standard size. Any percentage above that, you're going to drop down to the next standard size. The only time that that doesn't apply was here at transformers. If you got a note one in there, it says shall be permitted, so that means I can go up or down. But if it didn't have a note one, then we were dropping down if we were over 125%. Okay.
Right.
And then the other one you'll see we'll get into is phase conversion, because you got to protect the conductor, and the conductor is taken at 250%. Those are two of the
Right.
places in the NEC that I'm aware of that this rule of thumb doesn't hold true. Okay.
Yeah, and feel free. Here's the link to the Stallcup education website, and it's really awesome. I've been in there, James, and I checked it out. It's really dope, man. You got it really set up in there. I think that's gonna be a really good platform for you to launch everything from.
Yeah, we've got everything going in there right now, and I've also built up one of the things. We'll have a blog that I've started, and we'll have articles that'll be going in there. You can go over and see all this stuff. I haven't added any new ones. I did three to start off with just to get everything going, and we're already setting up for the courses online and everything. You can go over there and just like we were talking about the generator, or just say the journeyman prep like we're doing now. You'll go over and see it. There will be a write up. We've got cool graphics and all that, and you'll see that you can't go to the learning management system or anything, because we're going to tell you at the top it's coming soon. So
Right.
all of this is being, as everybody can see, everything is being developed left and right. I mean, uh, we do have the publications that you can go over there, and you can go purchase the hard copy. I will be setting up here eventually, as these are coming out in the PDF form. You can also get them in the PDF form, and I will have another write up underneath there where you can purchase it in that, and I'll have all the prices and everything on here. So uh,
Just out of curiosity, how many states are you trying to go for continuing education?
when we get going, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31, 35.
Nice.
Yeah, it'd be 35.
And just to let you guys know, just because Colorado's first doesn't mean it's his favorite. It just means he kind of owes me a little because he jipped me on a few code changes. So I gotta figure out a way to get my code changes back. So he started out by just putting Colorado first on his list.
Well, what I do is I go through, and when I build everything for the code changes, I do everything. And then I
Nice.
set up based on which ones have the most hours. So the two of your
Right.
top ones is California and Colorado. So I will get those set up, and then from there I peel off for the hours. Because
Nice.
I'll clone that and then rename it and everything, and then I'll start backing down everything. And then if I have like state law or something, I'll add another folder to put that in. That's part of it. So it's quite a bit of work, but I'll guarantee you when all this is done, this is the type of stuff you're going to see on there. Like this, this particular one here, like we're doing this calculation in the when you have the online version, you'll actually be able to take and where I'm giving you the answers here in the blank that are filled in here. Basically,
Nice.
when you go online, all you would do is just hover over that, click it, and then you fill in the value and work the problem. And then
Nice.
over here in the illustration where any of these sections are, all you have to do is hover above it, click it, and the sections will pull up, and then you'll have that you can do, and then there will be a video, just like I'm doing here, explaining it, and every the field populated as I'm explaining it, and then you can also click through the sections and everything. So it gives you one that you get to work it on your own, then you get the other with a video, me explaining it to you and giving you a lot of tips and everything as you're preparing for your test.
Yeah, and well, the one thing that I like about this is not only that you have all the code loops in there, but just the fact that it kind of makes you more confident because you're able to kind of put those formulas together. And I know that there's a lot of people out there because I hear it all the time that say that they want to go take the test, but they're scared of the calculations. And the thing I like about how you do this here is it makes you get these people like not scared of the calculations on the exam because if you can go through this with this fast like you do, just plug it in these numbers and get the correct answer, you're gonna pass that exam every time.
Oh yeah, it and I'll one other thing I'm going to do is I'm going to set up to where uh, I'll probably have like this online, and I'm probably going to charge probably like 49.95 a month. So
Okay.
if you studied for 6 months, it only cost you $300.
Yeah.
Or if you can do it in 3 months, it costs you 150. I'll guarantee you, most of the other programs out there, they're charging you anywhere from 500 to 1,000 to do it.
And
And you
probably what
won't.
I would do if I was in that case is I would get like the first month and then cancel and then just use it for the first month and then when I feel like going back then get a third month or whatever you want to do and then cancel that and then you know what I mean, you just study when you want to
That's right.
rather than just being hooked onto this program that you can't use. So I
Sure.
like how you have that set up.
Yeah, you can cancel anytime and then come back on and do it again, however you want to
so
do it.
like if so if you pay for 1 month then it doesn't matter, you can cancel and you still get the rest of that whole month.
Sure. Sure.
Yeah.
It's on a set time. And once you pay for it monthly, and then um, I'm going to do a question bank where you can go in and take the quiz over and over and over. There'll be 700 questions on there and over probably 250, 300 problems in there you can calculate. And after you answer it, say you answer it and you got it wrong, it's going to tell you where the section was. And then you can go look it
Nice.
up. And it'll plus tell you the answer. But you can go look it up. And then after you've taken, say, you know, 50 questions, you can go back and retake that 50 questions again. And when
Nice.
you take and do the problems, you work the problem. And then just like you're looking here, it'll be step by step showing you how we derive the answer. And
Nice.
and I'm going to set that up where it's only $10 a month. So
Nice.
I mean that is like super cheap.
Yeah,
And
dude. You might want to keep that in the wraps, man. There are a bunch of haters out there gonna get you on that one.
I don't care. I sell whatever I want.
Yeah.
All right,
Right
let's
on.
get into this. All right, now.
Sorry for interrupting. Sorry about that.
Oh no, it's fine. Don't bother me any. Uh,
Nice.
this in here, we're going to be doing uh, calculating the overcurrent protection device for the primary and secondary here. I'm sorry, for the primary only, and we're going to be doing it for circuit breakers and time delay fuses. Now, remember when we were talking about this last week, I said you want to go over and look at table 450.3a, and this one is a supervised location. So as you're looking at the table in the left-hand column, you're going to come down to where it says supervised. And as you're looking at this problem, we have a transformer. It's 1,000 kVA and 12,470 volt three-phase primary. Okay. Now, as I look at that, you're going to notice I don't have an impedance there. So when you're looking at that table, you're going to see where it says any. When you come across there, then you're going to be looking at primary protection. And of course, this is over 1,000 volts. And if I'm sizing the circuit breaker, it's going to tell me take it at 300%. And if I'm sizing the fuse rating, it says take it at 250%. Okay. So just like when we started this at the very first, and I was talking about if you had something in KVA, you're just going to take it at 1,000 to put it in VA form, and then just take whatever the voltage is, and then you're going to divide it into that KVA of the transformer or the VA after you get it in VA. And in this case, it'd be 46.3. And if I'm sizing the circuit breaker, we just discussed, you're going to take that at 300%. Now, one of the things I want to point out is when you look at that, you're going to see a superscript right there beside it that has a number 1 there. Okay.
Right.
That number 1 is going to come down, and they're basically telling you it shall be permitted. So here I could go down or go up. But in this case, we're just, most testing are going to have you go up to the next standard size here. So
Right.
if I take 46.3 amps at 300%, that's going to give me 138.9 amps. And then if I go look at table 240.6a, that's going to give you 150 amps. Now, one of the things that'll be interesting on the online portion of this, on the left-hand side, when this is laid out, I will have a code loop over there for you to follow. And I would tell you right away here, go to table 450.3a, then I would do 240.6a and table 240.6a. And then I would drop to the next one and say, all right, now let's look at table 450.3a again. And right here, you're doing the time delayed fuses, and it said to take it at 250%. That'll give me 115.75 amps. So I go down to table 240.6a, and the next size above that's 125 amps. Now,
Right.
That's not hard. All you had to do is just look at this table. See, I'm in a supervised location. I didn't have any impedance. Come across, look at my percentages, and go from there.
Nice.
That should be easy for everybody to follow. Now, one thing I want to point out is I'm going to do multiple calculations here on transformers for different types. But one thing you're going to notice is I do not change the format of my calculation. Okay.
Hey, just a quick question. What was the calculation that you did where you take the windings of the transformer? What was that? Where you took like the ratio of the transformer?
Oh, you talking about for a tap?
Yeah. Oh, that's what it was.
Yeah, I did that for a tap. I said if you had a tap that was uh, 25 foot up to 10 to 25 foot, and you had a transformer in there, the primary was taken at a third, but the secondary, it was taken at a third plus the ratio of the transformer.
Gotcha. Okay. Yeah, I didn't. That was the first time I ever heard that one. That was a good one.
Yeah, and that was another rule of thumb as people are getting ready to, study for their test and prep for it. I said when you're doing taps, just always remember if it's 10 foot or less, divide by 10. Everything else you take at a third. And if you have a transformer in a tap, the only thing that changes is you got to get the ratio of the transformer on the secondary side, but you still had the third based on the overcurrent protection device that's upstream.
Right.
Okay?
No, you'd have loved this, James. There was one day on the job site. Somebody's like, "Are you sure we got enough room for all them conductors?" And I went and just did the calculation real quick, and I was like, "Yeah, we could put 600 number 10s in there. You think we got room for that?" That was pretty funny.
Giving them a hard time.
Right.
All right. Now, this is non-supervised, okay? So when you look at table 453A, you're going to see your location limitations there, and you're just going to use any location here, okay? So it's other than supervised, okay? It's non-supervised. Now, when I look at this problem here, I'm going to do the primary and secondary, and I'm going to look at the illustration. I'm going to pull out the most important information. I've got a 500 kVA transformer. Now, one of the interesting parts here is I want to point out it has a 4.9% impedance. So when you're looking at that table, the second column is going to be your transformer rated impedance, and I'm not going to be more than 6%. So that's the column going across I'm going to use. Now the primary is 4160. It's a three-phase, of course, and the secondary is 480 volt, three-phase. So I'm going to do the same calculation, just like we discussed, when we first started all this. I've got my kVA there, time 1,000. So I got a 500 kVA transformer, time 1,000, 500,000. So I'm going to divide the voltage into that. It's going to give me 69.3 amps. Now, as I look at any location and I come across, and I'm doing the primary protection here, and I'm doing circuit breaker here, you're going to see it's at 600%. Okay? So I'll take 69.3 times 600%. It's going to give me 415.8 amps. I have a superscript 1 there, so I'm going to go up to the next standard size per table 240.6A, which is a 450 amp overcurrent device. Okay? Now, a lot of people look at this, but you're going to look at that secondary protection, and you're going to notice I'm 1,000 volts or less here. I got a 408 volt secondary, so I'm going to go all the way to the far right-hand side of the column, and it's going to tell me to take it at 125%. I have a superscript 1, so I'm going to go up to the next standard size. So I'll take the 500,000, divide it by 831 volts, going to give me 601.6 amps times 125%. Gives me 752.1 amps. Go to table 240.6A, the next standard size above that's 800 amps. Now, what I'll point out, I did one that was supervised without an impedance. Now I did one that was non-supervised with an impedance. But the thing I want to point out, did I change the calculation? No, I still follow the same procedure. You just got to know how to look at that table and pull the information out you need in order to know what the proper percentage is going to be. Right?
Yeah, and one thing I wanted to point out too, James, this is one thing I don't want you guys to read into. So just because we're showing you that calculation doesn't mean we're saying it's required by code. So a lot of times what James does is he just wants to make sure you know the math on both sides of it, but you really have to look at other sections of code because there's times where when you go in there, this could be only require primary protection, and you might not even need secondary protection.
Sure.
But we just want to make sure you know the calculation so you calculate both sides of it.
Well, yeah. I'm not going into all that. This is just for test prep because they could ask you the question just like this.
Yeah, I agree. I'm just saying there's some haters out there that like to, interject and say we're, creating code violations or something.
Always. Now, look at this. The exact same one we just did, but I'm in a supervised location. Now, the impedance is still 4.9%. Now, if I come down and I look in table 453A and I look at not more than 6%, you're going to see I'm going to do 600%, but I want to point something out. See where there's no superscript 1 right there? This means you're going to drop down because I'm above that 125%. Then if I come over and do the secondary, come across, looky there, 250%. There's no superscript 1. That means I'm going to drop down.
Right.
Okay. So I'm going to do the same calculation. I still came up with 69.4 at 600%. It's 416.4 amps. I I didn't have my superscript one there. So I said anything over 125% drop down unless there's something telling you otherwise. So the next size below that for table 240.6a is a 400 amp overcurrent device. Then if you look, the next one, we were not over 1,000 volts. So I come over to the far right-hand column. It tells me take it at 250% for not more than 6% impedance. And I'm going to take that 601.7 amps, the same amperage I had in the calculation before, at 250% gives me 1,543 amps. I didn't have a superscript, so I'm going to drop down the next standard size per table 240.6a is a 1,500 amp overcurrent device. Now, you look at that, everything was the same calculation. I'm just looking at the table and looking for my superscripts and getting my percentages and doing the same calculation to size that overcurrent device. Okay?
Right on. Yeah, we got another like come in. I appreciate you all hitting the like button. We
Well, thank
really
you, guys.
appreciate it. Don't forget to subscribe, and we'll keep bringing awesome content every week.
We try to. Now, this
you guys just always have to stay tuned to see how good James guesses on the Willie quiz.
I do pretty decent.
Yeah. Your
All
second answer is 100%.
Always on the second, baby. Now, this is where you're looking at my voltages here, and you're going to see this is where I'm less than what, 1,000. Okay, so now you're going to flip over and you're going to be looking at table 450.3b. You'll just go to the next page. You'll be on the top left-hand side of that page. Now, what is the information that's important here? Well, I got a 50 kVA transformer. I got a 408 volt primary, and I'm doing primary only here. Okay, so I got 50,000 divided by 831 volts gives me 60.1 amps. Now, I'm going to look at the table on 450.3b, and if I'm doing primary only protection and I pick up the column there where it's under primary protection and pick up a current of 9 amps or more, it tells me take it at 125%. And look there, there's that little superscript 1 right above it. So that means we're going to do what? Go up to the next standard size. So I'll take 60.1 times 125% gives me 75.1 amps. Go to table 240.6a, the next size above that's an 80 amp overcurrent device. Okay?
Right.
Now, the interesting thing, whether I was looking at doing the higher voltages or I'm doing the lower voltages, I'm still just looking at the table and picking out what is it they want me to size here. And then I'm looking for that superscript 1 in table 450.3a and b. All right?
Right.
Now, this in here is a 3 kVA. Okay, this is where the primary is 2 amps or more, but less than 9 amps. Now, if you look there in the table, you're going to see current less than 9 amperes. Okay, it's going to tell you take it 167%, but I'm going to point out here there's no superscript 1 right there. See that?
Right.
Okay, so that means I'm going to drop down. So I've got a 3 kVA transformer times 1,000 is 3,000 VA. I'm going to divide that by 480 volts is going to give me 6.25 amps. Then I'll multiply that by 167% gives me 10.4. I can't exceed that calculated load, so I have to drop down. I go look at table 240.6a. The next size below that's 10 amps. Okay?
Right.
Now, the next one is where I'm going to be dealing with a current that's less than 2 amperes here. Okay. Now you're going to see, looking in the illustration, I have a 0.8 kVA transformer, and I've got a 408 volt single phase here. So I'm going to take that 0.8 times 1,000 is 800. I'm going to divide it by 480 volts is going to give me 1.6 amps. And then you're going to look in that table, come across for primary protection only. It's going to say 300%, but there's no superscript 1 above that. Right. So that's going to give me 1.6 times 300% 4.8 amps, and I look at table 240.6a, and it's going to tell me that the next size below that's a 3 amp overcurrent device. Now, also, I can go over and look at 430.72C4, and it'll actually allow me to even go up to 500%. Okay.
Right.
So just take the 1.6 times 500%, it's 8 amps. Look over at table 240.6a. The next size below that is a 6 amp. Okay. And that's for the primary only. Now, this one is where I'm going to do the primary and secondary. Okay. So I got a 50 kVA transformer. It's 3-phase. I got 480 volts on the primary, 208 volts on the secondary. Now, when I look at this table and I pick up primary and secondary protection only, you're going to see I'm at a current of 9 amps or more, so I'm taking that 125%. And then when I look at the secondary, it says 125%. But isn't this interesting right here? Because the 125% has a superscript 1, but the one for the 250% doesn't. So
Wow.
I'm over that 100. That means I'm going to drop down on the 250%. So I'll just take the 50 kVA times 1,000 is 50,000 divided by the primary voltage, which is 480 volt 3-phase, is 831 volts, gives you 60.1 amps. And then I'm going to take that at 250%, gives me 150.2. I drop down to the next standard size for table 246A, which is 150 amp overcurrent device. Then I do the secondary, same calculation. The only difference is I'm going to divide it by 360. That's going to give me 360 for the 208 volt 3-phase. That'll give me 138.8 amps. Take it at 125%, gives me 173.5. 125% or less. I said you go up. The next size above that for table 240.6a is 175 amp overcurrent device. Okay.
Yep.
And if you look,
Nice.
I did the same calculation all the way through that. All I was doing was following what the table was telling me. And I was looking for that superscript 1. If I had a superscript 1, you went up. If it's 125% or less, you automatically knew you were going up. If I looked at any percentage in table 453A or B that was above that 125% that didn't have the superscript 1, what did I do? I dropped down.
Right.
Okay. Now here's a tap, and I've got a 10-foot tap here. Now I've said this before. If it's 10 foot or less, what do we divide by? 10. Take it at a 10. Okay. So my upstream overcurrent device is 1,000 amps. I take the 1,000 amps divided by 10, gives me 100. And then if I go look at table 310.16 in the 75 degree C column, the number 3 is good for 100 amps. So the overcurrent device and conductor matches up. So therefore you would need a 100 amp overcurrent protection device with number 3 conductors. Okay.
Nice.
And then we did a basic branch circuit third day. I said, if you have a continuous load and you look at Article 100, that means that could operate for 3 hours or more. You take it at 125%. Okay. So I'd take 15 amps times 125%, gives me 18.75 amps. Then you just use it like if it's a small conductor, and you could look over at 240.4D, but the next size for that would be a 20 amp with a number 12 wire. Okay.
Yeah, and one thing you got to look at too that I don't want people to get confused on, because it goes back into the definition of continuous load, is basically it has to operate at full capacity. Like, so it has to operate at full load for 3 hours or more. So a lot of people get that confused, and they think, oh yeah, it turns on and off, or it's on for 3 hours. But if it's not, like a refrigerator, like we got Juan Gonzalez, Mr. G, where it's like that refrigerator is not running at full power for 3 hours or more. So I just don't want people to get confused with that.
Sure. Now, one of the things I want to point out here is when you go over and look, we're going to start on motors here. Now, if you go over and look at 240.4G, the table, right at the top of that table, it's going to have a heading there. It says specific conductor applications. Basically, you're going to they're talking about this being specific because you're going to get into stuff that has higher percentages here. Okay.
Right.
A lot of stuff that's in here. So if I'm looking at motor control circuit conductors, it's going to say, look at Article 430, and then it's going to tell you to look at all these parts. Okay, so that means there's a lot of things we need to look at as we start to do these motors. So I brought this up, I've had people ask me questions while we were live, and I just made up a problem. But I'll just make one up different from this here, and I think we even have it maybe in one of the other slides we do. But let's say that I have a motor, and let's say I'm going to size an inverse time circuit breaker, all right? And we'll say it's a 50 horsepower, 460 volt, three-phase Design B squirrel cage motor. Now, when you look at this, and I'm going to size the overcurrent protection device, 240.4, table 240.4G is going to reference Article 430. And when you go over and look at that, 430.6A1 is going to be your starting point, because what it's going to tell you there is anytime you're sizing your conductors in your overcurrent protection device, you're going to use one of the tables in tables 430.247 through 250. Okay? Now, in this case, if I was doing a 50 horsepower motor, 460 volt three phase, I go over and I look at table 430.250, and I come down, pick up the 460 volt, and I come across, pick up 50 horsepower. It's going to tell you it's good for 65 amps. All right. Now, what I've always told people when I've been doing presentations, I've been out to all kinds of places. I'd tell them in their code book at this point, at table 430.248 and 250, because that's what you're going to deal with the most. I would have them put right at that table, I would say, I want you to put down 430.52C1 and table 430.52. Okay?
Right.
Now, the reason I want you to put those down, because that's where you're going to go get your percentages for your overcurrent devices. And then if you're dealing with your branch circuit conductors right there, I'd also have them put 430.22 and 430.24 for their conductor size. All right? So if I go over and you look at 430.52C1, what you're going to get into is, and this is important, and I want y'all to pay attention to what I'm telling you here. You're going to look at that section, and I want you to look at what it says. It says, in accordance with table 430.52. Okay?
Right.
Now, if I'm in the 2023, it's going to say C1. But the main thing when you're looking there is when it says in accordance with table 430.52, it says a protected device that has a rating or setting. Now listen to this, not exceeding the value calculated. So if you can't exceed it, that means you have to do what? Drop down. Okay? Right. Now, when we're doing this in our publications, we consider this a starting point as a minimum. You can go, if it'll allow to even go smaller, you can go smaller, but this is a starting point. So we got a minimum started there, because after you get that point right there, then you can go to the next size, and then you can go to the maximum size. Now, as you look at the table there, at the top of it, it's going to say maximum rating or setting. Now, let me explain this. I'm arguing with this with a bunch of those ECD boys, and I'm telling you, they don't know what they're talking about. But when you look at that, that is the maximum for the percentages in that table. You can't have two maximums. And the reason I'm telling you this is because if you look at 430.52 C1, there's an exception 1 and an exception 2. I can actually go up to a maximum size. In this case, we're doing an inverse time circuit breakers at 65 amps, which would put us at 400%. That's actually your maximum. This table here is the maximum percentage in that table as a starting point. Okay? So if I took that, if I have a squirrel cage motor and I come across and I'm doing an inverse time circuit breaker, looking at table 43052, I tell you take it at 250%. Well, if I took 65 amps at 250%, that's going to give me 162.5 amps. If I can't exceed the calculated value, that means my starting point is dropping down, and we're going to call that our minimum is going to be a 150 amp overcurrent device. Now, without doing anything further, I can look at exception one and just go up to the next standard size if it fails to start due to the inrush current, which in that case would be a 175 amp overcurrent device. Okay?
Dude, I'm telling you guys out there, you do not want to get James riled up when he's talking about motors.
Mm-hmm. I want to call them minotaurs. Okay.
That's so funny.
Now, here's an example problem. Now, this one I'm showing you on screen. I just did one just off the top of my head, and what I'm trying to point out, it's not that hard to do if you're going to the right sections and everything. That's why I have you sometimes write up your code book so you know where to go back and find the information. Now, this and I'm going to be doing a non-time delay fuse, and it's a 40 horsepower, three-phase, 460 volt design B motor. Now, I said you're going to start at 430.6A1, which tells me if I'm sizing the conductors and overcurrent device, then I can go look at one of the tables. Now, if you were going to do your overload protection, you would be looking at 430.6A2 and you'd use the nameplate value. But for this, you're going to use the table value, okay, for sizing your conductors and overcurrent device. So I look at table 430.250, I pick up 460 volts, come down, pick up 40 horsepower. It's going to tell you it's good at 52 amps, okay? So now all I'm going to do is I'm going to go back and look at table 430.52, and I come down and I'm looking at a non-time delay fuse squirrel cage. It's going to tell me take it at 300%. So I'll just take the 52 amps at 300%. That's going to give me 156 amps. It said in 430.52C1, I can't exceed the calculated value. So I drop down to the next standard size, which is 150 amp. Now, if they ask you for the next size, well, automatically I can go over here and I can look at exception one. Exception one tells me I can go up to the next standard size, which is 175 amp overcurrent device. Okay? Right. So that's how you size right there. Now watch. Now this will be your exercise problem for next week, and you'll see I've got a 50 horsepower, three-phase, 460 volt design B motor. Okay? Now, let's look at this one. I'm doing the exact same motor. I'm not changing any of this. All I'm doing different here is I'm going to do a time delay fuse. I already know I was at 52 amps. So all I'm looking at now is what percentage do I use for a time delay fuse? Well, if I look at table 43052, come down squirrel cage motor, it's going to tell you for time delay at 175%. Same calculation. 52 amps, only instead of 300, I'm doing it at 175%, gives me 91 amps. I can't exceed the calculated value, drop down to 90 amps. Then I look at exception one for the next size. The next size above that would be 100 amp. Okay? Right. Now, and you're going to notice, even when you come in and you do your exercise problems, I want you to look here. I'm using the same motor here. All I'm wanting you to do, I don't want you just, going all over the place. When I get to this motor right here, I know it's 65 amps, okay?
Right.
I'm going to do the same calculation. If I'm doing the non-time delay fuse, I'm going to do it at 300%. Here, time delay, I'm going to do it at 175, okay? Right. So everybody should be able to do this pretty easy if they're just following along, paying attention here. Now.
Yeah, so you guys should be able to go back to that illustration real quick. So you guys should be able to go dissect this equation, this calculation, just by going and following those code loops, and it'll tell you what all the values you need to put in those blanks,
Sure.
So that's what I really like about how you have it set up, James. It's real super easy.
Yeah, it is. And repetition,
Hmm.
and that's one thing. A lot of books publications, see, they only do one of these. We go through each one of them because repetition is going to get you there. Okay.
Yeah.
Now, this one is where you're going to look at 430.52C3. Now, the reason you're going to look at this, and this is an instantaneous trip circuit breaker. And you'll notice if you look over at table 430.52, you're going to come in, you're going to pick up your instantaneous trip breaker there too. Okay. But the only difference is when you get over here, we're going to be looking at doing the maximum here. Okay. And you're going to have a minimum and maximum setting here. There's not going to be a next size. You're doing settings here. And when you come over and you look at 430.52C3, it's going to tell you that you can take it up to a maximum of 1,700%, and that'll be an A3B, B2B, I think it is, something like that. So it's been a while since I've looked at that. Now,
Nice. Well, we got some more likes coming in the house. Awesome. Really appreciate everyone joining up. That's pretty awesome. 4
oh,
likes
there's
now.
Jeremy. Always can count on him. It is a minimum starting point. I mean, I don't know how many times. If you're teaching your guys in class any different than that, you're teaching them wrong, Jeremy. I don't care.
Yeah.
Now, this and here, the exact same thing. I'm doing the same calculation, the same motor and everything. I'm just looking at my percentages. And if I look at table 430.52 and I come in and I pick up my Design B energy efficient motor come across, it's going to tell you take it at 1,100%. So I just take the 52 amps at 1,100%, gives me a minimum setting of 572 amps. Then I look at C3 and then pick that up. It said I can go up to a maximum of 1,700%, which is 884 amps. Okay.
Right.
Now, I do want to put that back up there, that comment. Okay. Now, I want to point something out here. I'm gonna show people here, and I want y'all to go over and look at this. This is one of them things where we get some of the guys on here, and they want to disagree, and that's fine. I don't mind disagreeing, but I'm gonna prove a point here. Okay. Now, how many have taken and looked at an AC unit, looked at the nameplate, and it has the hacker breaker rating on there, and it says minimum and maximum? You ever seen that?
Me.
Yeah. Well, the reason that's the minimum. That's how it's established out in the field, and it's based on 440.22A, and it'll say it cannot exceed, once again, that calculated value at 175%, and then if you go to the very maximum, then it allows you to go up to 225%. Well, in the 2023 code, this is interesting. Now, I would ask this: how do you think the manufacturers determine the minimum and maximum size for that overcurrent device? Well, when they design their equipment and everything, it's designed based into consideration what the code is. Okay? And I can go through many, many examples showing you where the National Electrical Code is used, and how the manufacturer would have to take that into consideration, plus their own UL standards or any other standards that might affect that piece of equipment to get that listing and labeling for that piece of equipment. Now, in the 2023, this is interesting. Now, they based it and they put minimum on their nameplate. Okay. Now, I'm not saying every AC unit has minimum maximum, but they do. There are ones that do have minimum and maximum. Now, when you go and look at the 2023 version, it's very interesting because guess what they changed it to look like? It looks like I'm looking at 430.52. Okay.
Right.
C1. And now they have an exception 1, and it basically says the same thing. If it fails to start due to inrush current, guess what I can do? Automatically go up to the next size. And then they moved the 225% from the full code text. Now it's down in exception 2 and allows you to go up to 225%, which would be your maximum.
You know
So
what? You know what? You know what 225% is?
I'm not sure
It's
what you're
tens on
asking.
a 50. Tens on a 50.
Oh,
We
okay.
can have tens on a 50, everyone out there.
Okay. Well, and if you look at that, that's that's why I pointed out that way. If you just go look at what they did in other sections of the code, and I you've heard me say this many times. I look at all the code, and I pull out different parts all through the code to see if we have everything is lining up. And they've done this, and you go look at 440.22a now, and look at that and see if it doesn't look like what it is over in 430.52c1 now. And then
Right.
tell me, how did they determine a minimum and maximum on the AC unit for your
Seems like
active
Jeremy
equipment?
must be out there. Seems like Jeremy must be out there drinking a little bit. He's like talking about the Morat. Morat.
Moron. He's trying to call me a moron. I tell you, he is just eat up with it, boy. He just, man. I got an idea. Why don't you do your own podcast, Jeremy? You know, uh, every time we do something, any post I make, him and Fritz and Mickles, all of them, they just start trying to hammer anything I do, and I know why they do it because they're simping for Ryan and Mike. But
Yeah.
that's okay. It doesn't bother me.
Well,
But
and we enjoy it. We're doing it for free. We're bringing free content to our listeners out there. Really appreciate it. We're up to 5 likes now. Thanks so much for smashing
oh
that
wow,
like button.
yeah,
And the whole thing is that everyone's loving it more and more. I hit 100,000 this week, and it's really awesome that everyone's participating, have a good time doing this. And we're gonna make sure you pass that test and you get that license. So make sure and pay attention to these illustrations that James has up now, and then that'll be your homework for next week. And all you have to do is just fill in the blanks.
sure. And and I'll give you a good example. Like this is the same motor that is in the other exercise problems, but I can point out, look at that, look at the new equipment that's been drawn, and you see the full enclosure with the instantaneous trip circuit breaker in it. And we're showing you everything there, where all the overloads and all the control wires connecting it back and forth and all that going to the motor. That
Yeah.
that's some high detailed illustration work that's been done.
The
And
only problem is you didn't show an outlet.
yeah, well, it's because there's not one. I find it interesting because they're saying that, and I said, when you go to that Peckerhead, I said, I'd ask this question. Well, if that's true, I said, why, when you go over and look at 430.12, it says motor terminal housing. It
Yeah.
doesn't say motor outlet housing. It says terminal
Yeah.
housing because it's nothing more than a termination. But anyway,
Yeah.
I don't want to. I'm gonna get off of that because I want to get going on
No,
this.
that's good. We'll get you. We'll get you finished up. Everyone's waiting for the freaking question and the tool anyway.
Oh yeah. Now this one we're getting into is inverse time circuit breaker. Same thing here. I've got the same motor, didn't change. The only thing I'm looking at, I got a squirrel cage motor. Come down for an inverse time circuit breaker. It tells you take it at 250%. So you take the 52 amps at 250%, gives you 130 amps, says you can't exceed the calculated load, so I have to drop down to 125 amp. Then exception 1 allows me to go up to the next standard size if the motor fails to start due to inrush current, and per table 246A, that'd be a 150 amp overcurrent protection device. Okay? And then when you come over here, same motor that I have in the other exercise problems. You're just doing an inverse time circuit breaker. Okay?
All right.
And that is gets that portion going. Now I'm going to look at determining the maximum. Now you're going to see I got the same problem we did earlier. The only thing I'm going to do different here is I'm going to come down and I'm going to look at 430.52C1, and I'm going to come down and pick up exception 2A, In exception 2A, I'm not, I was just sitting there. Okay, I was looking at something. Okay, so I'm looking at exception 2A. It tells me I can go to 400%. So I take the 52 amps at 400%, gives me 208 amps. Once again, it says I can't exceed what? The calculated load. So the next
Sure.
size below that for 246A is going to be a 200 amp overcurrent device.
Right.
Pretty simple. All right.
Yeah.
Then if you look here, same motor that we did earlier for the non-time delay fuse. The only thing I'm doing here, I can tell you it's 65 amps, so I'm going to take it at what? 400%. Okay?
Right.
Then if I come here, look at the next one. Here's a time delay fuse. I'm going to come down and I'm going to pick up exception 2B. And when I pick up exception 2B, it says I can take it up to what? 225%. So I take the 52 amps at 225%, it's 117 amps. Says once again, I can't exceed the calculated load. So therefore, I'm going to drop down to the next standard size for table 246A, which is going to be 110 amps. Pretty simple. And then looky here, same motor, same voltage, everything. You're going to get that amperage and take it at what? 225%. Then I go to my inverse time circuit breaker. Come down, I'm going to pick up exception 2C. It says I can take it at 400%. So 52 amps at 400% is 208 amps. Once again, it says I can't exceed the calculated value. I drop down to the next standard size is 200 amps. Okay? And you know, it's interesting because I did this exact same thing, made these problems up. I was on NEC Live, and I was explaining the rule of thumb. If you take anything at 125% or less, go up the next standard size. Any percentage above that, you drop down, except for the things that I discussed earlier. And as I was going through that, I remember Derry goes, I've never heard that before. And I said, well, do the calculations and see. And as I was going through them, he goes, damn, it is right, isn't it? I said, yeah. So
who do you think suggested to him that they have you as a guest?
I think you did.
But yeah.
You know, it was interesting to this day. When I did 2 consecutive weeks, and I think I'm the only one they've ever, well, Derek told me, I was the only one they've ever had on where there were over 100 people each time. I think one time it got up to 186 or something like that.
Yeah.
And he said they just couldn't believe that many people showed up. But yet, if you listen to the guys over at ECD, nobody cares what you or I have to say, but yet there's 180, and they've never even had over 100 before. I think the most there has like 70 or something.
And the electrical code discussion for awesome electricians is a group that I created, and James is admin, and it's automatically up there as far as rankings on the social media. So if you guys are looking for a good code discussion group where you don't want to be ridiculed, don't want to have all the spam, don't want to have all the stupid things jumping in, and check out the electrical code discussion for awesome electricians. I've been handling all the spam people, like they're getting shut down, so
yeah,
we're getting there.
I've been sort of trying to keep up. We got another one that is electrical codes and standards discussion, because we do
that's your group. That's your group. That's doing good too.
I just started it, and it's almost at 1,000 people. I mean, I just started it. So, and that's really growing, but I've got a lot of plans for that one, because that's the one I'm going to, once I get everything completed and I'm writing the articles and stuff, the articles are going to go in there that link to the website and everything. So
nice.
Now, this one is where I have multiple motors. I've got a 10, 15, 20, and 25 horsepower, 3-phase, 460-volt design B motors. Now, just like we did when we were doing the conductors, you're going to take the largest motor at, in this case, since we're doing an inverse time circuit breaker, you're going to look at table 430.52, and it's going to tell you to take it at 250%. Now, I will tell you until um, uh, I guess it was, I think, was it 2017? I think they made this change that we did this, but we used to round down on the overcurrent device, then add them all together, then round down. Well, they did. They come back and they said no. They had in their substantiation, they wanted to take and round up first, add them all together, and then drop down. Okay.
Okay.
So that is one little difference that we had in ours that they clarified. So if I go look at table 430.250, uh, and I pick up my 460 volt and come down, a 10 horsepower is good for 14 amps. A 15 horsepower is good for 21 amps. 20 horsepower is good for 27 amps. And a 25 horsepower is good for 34 amps. So go look at table 430.52, pick up your inverse time circuit breaker. It says take it at 250%. And I take that 34 amps, 250%, it's 85 amps. I'm going to round up to 90 amps, add the rest of the motors together, gives you 152 amps. And then you'll see here, then I drop down. Okay. So that is one of the little differences there. We didn't round down here at the first. We rounded up, then added, and then we rounded down. Okay. So that's the way they want you to do that now. And then this here, you've got your different motors here. They're 460 volt, 3-phase. Design B motors. We're sizing an inverse time circuit breaker. And you have a 15, 20, 25, and 40 horsepower for your exercise problem. All right. And then do this overload protection to them. Then we'll call it quits on this one. All right. So we're going to ask you what the minimum overload protection is for a 20 horsepower, 3-phase, 460 volt Design B motor, and it has a nameplate rating of 58 amps. We're going to tell you it has a temperature rise of 40 degrees C and a service factor of 1.15. Now, when you get over and you look at 430.32A1, okay, that's where you're going to pick up your minimum. You'll remember I stated this earlier. I said, if you're doing the overload protection, you're going to look at 430.6A2, and you're going to use a nameplate. If I'm sizing the conductors and overcurrent device, then I'm going to be looking at 430.6A1 and using the tables. Okay. So the nameplate value here is 58 amps. Now, as you look at 430.6A1 for your separate overload device here, it's going to tell you motors with a marked service factor 1.15 or greater is 125%. Then motors with a marked temperature rise of 40 degrees C or less, we're at 40 degrees C or less, 125%. I have to meet both of those. If I didn't, then I would do it at 115%. Okay?
Right.
And you want to look at 430.32A1, and you'll see they'll be listed out right below the text with 3 of them there with the percentages there. So if I'm at 125% for my service factor and temperature rise, I'll take that at 125%, and that'll give me 72.5 amps for my motor overload protection. Okay? And then you'll come here, you'll see we got it set up here with our overload protection and everything, and we're telling you here we have a nameplate value of 62 amps, it's 40 degrees C and 1.15. I know that's 125%. Okay.
Right.
Now, this one is where you're going to get into the maximum, and you're just going to come down and you're going to look at 430.32C. And when you pick it up, you're going to see the same layout right after you get past the text. Then you're going to have your service factor at 1.15 or greater. That's 140%. If it's 40 degrees C or less, 140%. If it doesn't meet both those, then you go at 130%. Okay. So I'm looking here, my temperature rise and service factor meet up. So I know I'm going to do this at 140%. So I'll take 58 amps at 140%. That tells me the maximum size of the overload protection is 81.2 amps. Okay. And then here, same motor, 62 amps. I meet my temperature rise and service factor, so I know I'm going to do this at 140% when y'all do your exercise problems. All right. And we're
All right.
going to stop right there for tonight, if that's okay.